Hey everyone, welcome back. We are in chapter 10, slide 39. We're wrapping up chapter 10. We've talked all about muscle tissue, focusing mostly on skeletal muscle. Here we're still talking about skeletal muscle, but not so much about the histology of it, though somewhat related. We're talking about fascicles and different terms that will help us understand the next chapters when we talk about whole muscles. We've learned about how skeletal muscle has muscle fibers, the individual cells, and they're really long. And then those fibers are bundled into fascicles. The way that a fascicle is arranged, it depends on which muscle we're talking about. Sometimes they're arranged such that, let's go with the example of this biceps brachii. Sometimes they're arranged such that the tendons are on either side. And then you've got the muscle running end to end. The fascicles are running end to end. In this type of arrangement, all the fascicles are next to each other, lengthwise, tendon on either end. We call that a parallel arrangement. It's called a parallel arrangement. Now, sometimes it's perfectly, just like one on one tendon on one end, one on the other. It gets a little more complicated, say with the rectus abdominis, the abdominal muscles, where you have actual sections, but still you have tendon on either end. Some muscles which are narrower, you still have tendon on either end, or even larger ones like this pectoralis major down here. You have tendon on one end and then tendon on another. They're much different sizes, but they're still on either ends. And you have fascicles running parallel next to each other. The advantage of having muscles where fascicles are running next to each other like this, that allows muscle fibers to be long. If the muscle fibers are long, that means you can change force easily. I've listed some muscles here. You may not know if they are quite yet, so those are just for future, but laryngeal muscles, the muscles surrounding your larynx for speaking and swallowing, you can change the direction of them pretty easily, relatively. Sartorius is a muscle in your leg. It helps you cross your legs over. That's a big range of motion. In some cases, like with the biceps brachii, that allows you to concentrate force on a small area by having these muscles run parallel. And then when you have them branch out a lot, you can change the direction of pull easily. With your pectoralis, you can move your arm in many different directions. So there's advantages to having fascicles that are arranged in a parallel way. There's other terms here to describe different types of parallel, like these tendinous bands and wrapping or convergent. I'm not going to test you on that. We'll focus on how they're all parallel. The fascicles are arranged in a parallel way. What could be different than parallel? Something called pennant. Pennant is where the tendon, let's take a look down here. The tendon is running all along the side. And then the fascicles branch off the tendon. Or maybe the tendon runs through the midline. So everything I'm coloring in green here is tendon. And then branching off that central line, you have muscle fascicle. Or more complicated, you have tendons running through 3 different parts. In this example of the deltoid, here in this cross section, you can see that there's tendon in the middle, and then branching off of that, you have fascicles. In either of these situations, it's kind of feathered. Pennant means feathered. Looks like a bird's feather. A bird's feather looks not quite like this, but something like this, where you have a central quill type thing, and then the feathery, I don't know feather anatomy, the parts of the feather come off. It's like that. This is how it differs from parallel, rather than having tendon on one end and then running all the way across. These are much shorter. Overall fiber length is shorter. What's the advantage of having a shorter fiber length? You get more fibers, which means you produce a greater force. More smaller, but more muscle fibers are in a smaller area, create more force. I've listed examples here that, again, if you don't know what they are, we'll go over them later, but these are examples of ones that are pennant. Tendons run through the muscle, making the muscle fibers and fascicles shorter. The third category, parallel pennant, the third one is circular. The fascicles are arranged in rings, or at least give the appearance of it. So if you look at this muscle around your mouth, these fascicles are arranged in a circular fashion. By being circular, they can close and open. When they contract, they close, and so you're regulating the passage of whatever it is, of air, of food, of feces out of your anal sphincter. So examples of circular muscles are sphincters. Your orbicularis oris is around your mouth. Orbicularis oculi is around your eyes, to close your eyes. That's your orbicularis oculi. And then your anal sphincter, your external anal sphincter, is also a circular muscle. So those are our three arrangements of muscle fascicles: parallel, pennant, and circular. Regardless of the skeletal muscles always need attachment points. If you're going to move your skeleton, they need to attach to something, or even move your skin sometimes. Like to move our face muscles, you're actually attaching to skin. But you need at least 2 attachment points to cause a pull, to cause a movement, because remember, muscles pull. The 2 terms for our attachment points are origin and insertion. The origin tends to be more proximal if we're talking about a limb, or more towards your midline if we're talking about an axial muscle. It's the one that remains stationary. It's your anchor. So in this picture here on the right side, we're looking at the biceps brachii. It actually has 2 origins. Has an origin right here. Actually not right there, sorry. Has 2 origins. One is right here and one is right here. It's more proximal, and by being more proximal, it can then pull on the more distal insertion point. There's actually 2 insertion points for the biceps brachii, here and here. We're going to go over certain specific origins and insertions as far as memorizing, but in an activity we'll talk about, you will look up what specific muscles, origins, insertions are. Basically, if it's a bone marking that we have discussed, you should know it, if it's an insertion or an origin or an attachment point for a muscle. So muscles have at least 1 origin and 1 insertion. This muscle, the biceps brachii, happens to have 2 origins and 2 insertions. But you need that point of where you can grab and pull. This muscle grabs and pulls and shortens, so it causes flexion here at your humeroradial ulnar joint. Muscles often come in pairs, because when we move a joint, if I flex at my humeroradial ulnar joint, I also want to bring it back to extension, flexion, extension. So when I talk about pairs, that means there's a muscle on one side to cause this movement, while there's a muscle on the other side cause the opposite movement. The term for these pairs, I'm actually gone ahead here. The term for these pairs are antagonists. The one that does the opposite movement is an antagonist. let's say, let's go back. Let's say we're talking about the biceps brachii. That causes flexion. Since we're talking about flexion, that means it's an agonist because that's the main movement. It's the prime mover. The biceps brachii causes flexion, so that's our agonist. The antagonist, the one that causes extension of the same joint, that's the triceps brachii. Here in this example at the bottom right now we're talking about extension of the knee, of the tibiopatellofemoral joint. To cause extension, that would be these muscles here on top. They're part of a quadriceps femoris. So those are the agonists if we're talking about extension. If we're talking about flexion of the knee, that would be these muscles down here, the hamstrings muscles. So those are an antagonist pair. I have other examples here. The deltoid causes abduction, while the latissimus dorsi and pectoralis major, so these are both ones that cause adduction, so these are antagonists. If we talk about flexion instead of the knee, that means these hamstrings muscles become the agonists, while the quadriceps muscles become the antagonists. It's all relative to the motion we're discussing. This is simply my preference. When we talk about how muscles act, what movements they cause, I'd like you to refer to the specific joint. So the biceps brachii muscle, it causes flexion. Specifically at the elbow, it causes flexion of the humeroradial ulnar joint. You could say that it flexes at the antebrachial region. We'll just talk about the joint that's being moved. The biceps brachii causes flexion at the humeroradial ulnar joint. The triceps brachii causes extension at the humeroradial ulnar joint. That wraps up chapter 10. So I hope you enjoyed this chapter. Let me know if you have questions. Please let me know if you need clarifications, discussion, comments. Yeah, thanks. I'll see you next time.